All right, so section 7.3, similar polygons. We're going to talk a little bit about similar polygons and then we'll move our focus back into triangles. But our learning target for today is I can find the scale factor of similar polygons. And I can find missing side lengths of similar figures. So first we're going to start out, we're going to define the word similar. You guys have heard the word similar in everyday speech. There's some things that are the same, but not exactly the same. They do have some differences. So there are two pieces to this. Angles. In similar figures, angles are congruent. Sides are proportional. So that's why we did that little mini lesson on ratios and proportions, because we're going to talk about them a lot here. So in a similar polygon, they are polygons with the same shape but different size. So it's going to be the exact same shape. It's going to be a triangle. One side's going to be, if one side is longer than one, the similar figure is also going to have a side that's longer, but their sizes are different. So the two things, we know that polygons are similar if corresponding angles are congruent and corresponding sides are proportional. So the ratio of corresponding sides is called the scale factor, and we talked a little bit about this in section 7.1. The scale factor can either be, it's going to be one of two things. It's either going to be an enlargement or a reduction. If it's an enlargement, our scale factor is greater than 1. If it's a reduction, it's between 0 and 1. Another fun fact, if polygons are similar, their perimeters are also are proportional. So, scale factor. This order matters. The order matters in almost everything we do in geometry. It mattered in chapter 4 when we were writing congruent statements. So they want to know the scale factor that's going to take ABC and make it DEF. So the first thing I want you to notice is that it's getting bigger. I'm going to put an E here for enlargement. So with an enlargement, we know that our scale factor K has to be greater than 1. So how do I make sure, So from ABC to DEF. All right, so I'm starting with, if they want this to this, we're going to write it as a ratio, Okay, we're not determining, we're writing it as a ratio, so I want to start with triangle ABC. So pick a side, any side on triangle ABC. So I'm going to start with AB. Now, since we listed AB, I know it's proportional to the first two over here, so it's proportional to DE. So the scale factor of ABC to DEF is going to be 8 over 12. Okay? ABC to DEF. You might see it written in a different scenario like this. Now, like before, we have to make sure that we divide. Okay, we want this to be reduced. So I know that 4 goes into 8 2 times. I know that 4 goes into 12 3 times. So my scale factor is 2/3. Now, the ratio from DEF to ABC, well, things are going to switch. We want to start with our DE, 12, over our AB, 8. It's going to reduce down to 3/2. All right, so the scale factor of DEF to ABC is 3/2. Now, what is the ratio of the perimeter? Okay, well, if they want us to go from DEF to ABC, this is also going to be 3/2 because we want them to be the same. DEF to ABC, just because we used a side to figure this out, the perimeter will work the same way. It's 3/2. All right. Now, when we're finding a scale factor and we're trying to determine, excuse me.